Hello, my name is James Hunt. I am currently one of the students taking History of Mathematics at Roosevelt University. This is my report on the famous woman mathematician Sofia Kovalevskaya. Join me as I take you into her life story by talking about the famous accomplishments she made in the field of mathematics, in the fields of calculus and algebra, and the discoveries she made working with sequences. Sofia Kovalevskaya was born on January 15, 1850 in Moscow, Russia, the daughter of Vasilij Kurakovsky and Elizaveta Feodorevna Schubert. Her parents were both in the Russian army as artillery generals. Her parents introduced her to mathematics by papering walls of works by Ostrogradovsky on differential and integral analysis. This would later make her get involved in calculus. She became interested in algebra as a teenager after reading Berdan's book of algebra, where he talked about the different methods for solving equations. She was homeschooled for her school years in childhood and tutored at home in every subject ranging from math and science to history and art. She never attended school in person until she went to college, when she attended the University of Göttingen and Heidelberg University in Stockholm, Sweden from 1868 to 1874. She graduated with a Ph.D. in mathematics from the University of Göttingen in 1874. She died on February 10, 1891 in Stockholm, Sweden after battling influenza and pneumonia. She was 41 years old. However, her parents and teachers weren't the only influences she had on becoming a mathematician. She was influenced to become a mathematician from listening to lectures by other mathematicians, one of whom was Karl Weierstrass. He showed her that integrals and sequences can converge and diverge. This is where Sofia got the idea to test out sequences. She discovered that even power series and sequences converge and diverge when they get closer and closer to a number, for example 0. This later led her to develop the formulas for arithmetic sequences and series, which are a to the nth term equals a to the first term plus n, which is the number of terms in a sequence, minus 1 times d, the common difference in a sequence. And the formula for an arithmetic series is the series of the number of terms equals n divided by 2, the number of terms divided by 2, times the a to the first term, so the first term plus a to the nth term in the sequence, or the last term in a sequence. After viewing and listening to the lectures of different mathematicians, including Weierstrass, Sofia wanted to get her name out there, as developing formulas for sequences in calculus and algebra was done by her. She also proved that they worked. She couldn't, however, because she faced numerous obstacles. A couple included was one when she brought her work to the University of Göttingen, but they accused her of plagiarism because her ideas were based off of Weierstrass, and no one knew how much work was actually her own. Because of this, she almost did not graduate in 1874 from that university with the Ph.D. in mathematics, and almost had to start all over with her college classes. She also had difficulty finding a job, but later got one at the university she attended in 1876. No one wanted to hire her because they were skeptical about her findings. They did not know if she was an honest woman, since the university thought most of her work was actually taken and copied from Weierstrass. So how did she contribute to mathematics exactly? She contributed to mathematics by developing formulas and proofs for arithmetic sequences and series in the field of calculus and algebra. She also contributed to mathematics by analyzing and developing proofs for integrals, power series, and differential equations in the field of calculus. I have also included a picture of her theorem on power series from wherewearemobilefirst.com. Not only did Sofia do work in the fields of algebra and calculus with differential equations, integrals, sequences, and series, she also did work in the field of geometry with shapes. She discovered several characteristics about shapes, specifically spheres and pyramids. One big discovery she made in the field of geometry was about Saturn's rings. She discovered that the rings were elliptic, and she used what she knew about divergence from studying Gauss's divergence theorem to prove that the rings were elliptic. She calculated the potential energy and compared it with Gauss's theorem and formula for total energy. Using these results, she was able to write a proof that Saturn's rings were in fact elliptic, which I will display on the next slide. Gauss's theorem stated that the surface integral of a vector field over a closed surface is equal to the volume integral of the divergence of a vector field over the volume enclosed by the closed surface, according to physicswave.com. This is a picture of the Euler equations that Sofia used to prove Saturn's rings were elliptic, where I is the operator whose matrix is the inertia tensor for the body. If infinity is the angular velocity of the body, the origin of is the fixed point in the body. Y is a vertical vector of unit length. M is the mass of the body. X is the location of the center of gravity of the body. And G is the acceleration of gravity. This is a picture of the proof of Gauss's divergence theorem, which Sofia used to base her ideas about Saturn's rings and prove that they were elliptic. Next, I would like to share some interesting facts I learned about her from doing this research report. Sofia actually paved the way for a woman to study at universities in Sweden, as she was the first woman to be allowed to study at a university when she studied at the University of Stockholm. Her father was disappointed in her efforts to get women to study math and other subjects like literature, as he believed women in Russia shouldn't have these rights. He forced her to move to Germany and get married. He then gave her a direction to live as she was told, quote unquote. Moving her to Germany also gave her a chance to discover literature she says she, quote, wished she had access to in Russia, end quote. She developed an interest in literature and decided to travel to Europe to see what contributions she could make towards literature. She then returned home and moved to Sweden, and she thought she would have better opportunities. However, once she moved to Sweden, she passed away from influenza on February 15th, 1850, before she could even get started with researching literature. She was 41. She was also battling pneumonia when she died. Now I'd like to share what I learned overall from making this report on Sofia Kovalevskaya. I learned that women did not have it easy in Europe during her lifespan. They did not have very much freedom, as they either had to become a nurse or work in the army for a career, according to www.mathwomen.agnescott.edu. The reason for their lack of freedom for picking careers in Europe was because people believed women were incapable of contributing to a lot of fields, math being one of them. Sofia showed them that this wasn't the case, because she contributed to math by developing the formulas for sequences and proving theorems for sequences and series in calculus. Therefore, women were allowed to get jobs as teachers, authors, and many more career options. So Sofia not only contributed to math, but she also made a lot more options available to women when it came to choosing a career. I hope you enjoyed listening to my report on Sofia Kovalevskaya. Here are my references that I used when doing my research. Thanks for listening. Have a nice day.